In this video, we look at example 3.3.4. Consider the following augmented matrix in REF. For which values of k does the corresponding linear system have a unique solution, no solution, or infinitely many solutions? In order to determine the number of solutions of the corresponding system, we know that we want to compare the rank of the augmented matrix, the rank of the coefficient matrix, and the number of variables. Now, what's different in this problem is that we have entries in the augmented matrix that include a variable k. Depending on the value of k, those entries may be 0. And if they're 0, then they affect the rank. Now, k squared minus 4, that's a difference of squares. We can write that as k minus 2 times k plus 2. And so the values of k that can affect the rank are 2 and minus 2. If k is equal to 2 or minus 2, then k squared minus 4 is equal to 0. And if k is equal to 2, k minus 2 is equal to 0. So let's look at those cases. What if k is equal to 2? Well, then we have a new augmented matrix. In the first row, we have 3, 1, 2, 1. In the second row, 0, 2, 5, 7. In the third row, we have 0, 0, 0, 0. That's if k is equal to 2. And so what is the rank of this new augmented matrix? How many leading entries do we have? 1, 2. And so the rank of the augmented matrix is 2. And the rank of the coefficient matrix is also 2. Therefore, the corresponding linear system is consistent. Now, what is the number of variables? The number of variables is 3, which is not equal to the rank of the augmented matrix. And so therefore, the corresponding linear system has infinitely many solutions. Now, what about the case when k is equal to minus 2? What does the augmented matrix look like in that case? The first two rows are again the same, 3, 1, 2, 1, 0, 2, 5, 7. The third row becomes 0, 0, 0, minus 4. That's the new augmented matrix. And so what is the rank of this new augmented matrix? How many leading entries does it have? 1, 2, 3. So the rank of the augmented matrix is 3. What about the rank of the coefficient matrix? The rank of the coefficient matrix is 2 in this case. Since 3 is not equal to 2, since the rank of the augmented matrix and the rank of the coefficient matrix are not equal, the corresponding linear system has no solution. Now, what if k is not equal to 2 or minus 2? What about all of the other cases? Then what does the augmented matrix look like? First two rows are the same, 3, 1, 2, 1, 0, 2, 5, 7. And the last row is 0, 0. And then k squared minus 4 and k minus 2, those are non-zero real numbers. So here star denotes a non-zero real number. And so what is the rank of this augmented matrix? Well, how many leading entries do we have? 1, 2, 3. We know the star is a non-zero real number, and so it's a leading entry. And so the rank of the augmented matrix is 3, and so is the rank of the coefficient matrix. Therefore, the linear system is consistent. Now, how does the number of variables compare to the rank of the augmented matrix? Well, the number of variables is 3, which is equal to the rank of the augmented matrix. And so therefore, the corresponding linear system has one solution. So what have we found? Let's summarize. We found that when k is not equal to 2 or minus 2, we have a unique solution. When k is equal to minus 2, we have no solution, and when k is equal to 2, we have infinitely many solutions. So the solution to this problem is part A, k not equal to 2 or minus 2, part B, k equals minus 2, and part C, k equals 2.